Hey guys, welcome to question 15. So, looking at it straight off the bat, it is quite a bit of a long question, as you can see, but overall, it's much more intimidating than it actually is. So, I will probably skip the explanation. I'll let you guys maybe pause and read it if you want to, but we'll go straight into the sort of question. So, part A, I, we have, by considering horizontal and vertical components of the forces at P, show that tan theta equals tan phi plus mg over T2 cos phi. So if you guys can hopefully see, we have that the horizontal and the horizontal and vertical components of the forces should be equivalent if they're balanced at all times, as you can see from the first paragraph here, which means that, just looking at it straight off the bat, we have that, let's write it down, T1 cos theta, so you guys can see here, adjacent over hypotenuse, equals the T2 cos of phi. So this is for the horizontal forces. All right. So no other horizontal force, so just this bit and these bits should be equivalent. Now for the vertical forces, we have on the top T1 sine theta, which is this bit, is equal to, so we also have mg this time, so that's for gravity, plus T2 sine theta as well, which is just the vertical bit of T2, which is the tension. So now we just divide both sides. So we want to have, let's call that equation 2, equation 1, so equation 2 divided by equation 1. So T1 sine theta over T1 cos theta is equal to mg plus T2 sine, oh, whoops, that was meant to be phi, sorry guys, T2 sine phi over T2 cos phi. And if you divide that out, left side becomes tan theta. So T2 sine phi over T2 cos phi is just tan phi. And mg can't divide, so that just stays as T2 cos phi. So very intimidating, very scary, but just remember your forces. If something's balanced, add up all the vertical and horizontal components. And from there, we just got our equation here. And that will be it for part I. So for part II, we have, hence or otherwise, show that the point P cannot be lifted to a position 2h over 3 meters above the floor. So using our equation, so I'm just going to directly lead from there, we have tan theta equals tan phi plus mg over T2 cos phi. So what is tan theta specifically? So if you guys see, what's the opposite side? It's that. So tan theta is equal to L over D. So that's the adjacent side. Is equal to tan phi. So what's phi? We want the opposite of phi, which is this side. So that's, we don't have a direct number, but we do know that this whole thing is h, this thing is L. So the only bit left over for that is h minus L. Over, and we know the adjacent is 2D. So plus mg over T2 cos phi. So I'm not going to bother with that. The main reason is we know that if L over D is equal to this equation on the right hand side, then we also know for a fact that, well, everything here is also greater than LD equals H h minus L over 2d plus mg over t2 cos phi is strictly greater than h minus L over 2d on its own. Yeah, because mg over t2 cos phi is going to be positive since it's adding onto the force. And from there, we know that, well, the height of P above the ground is given by h minus L, right? So that'll make our life a lot easier to deal with if we just use that to our advantage. So L over D is greater than, h minus L over 2D. So bringing both sides up, that's 2L is greater than h minus L. And, well, we can rewrite that as h is less than 3L, or h over 3 is less than L. So finally, we have, well, the height of the machine above the ground is h minus L, which is going to be less than h minus h over 3. So that is just going to be h minus L, therefore less than 2h over 3. So because h minus L is the height of the machine above the ground, therefore height of machine always less than 2h over 3. And that will be it for part II. So very intimidating question, but overall much more easier than it looks like. Next, for part B, we have the diagram show two positions of a single piston in the cylinder chamber of a motorcycle. The piston moves vertically in simple harmonic motion between a maximum height of 0.17 meters and a minimum height of 0.05. Mass of the piston is that piston completes 4 cycles per second. What is the resultant force on the piston in newtons that produces the maximum acceleration of the piston? Give your answer correct to the nearest newton. So if you guys see forces, your mind should immediately go into Newton's second law of F equals m times A. So we already have m, our mass is 0.8 kilograms, so that's easy find. So the only thing left to find is A. So how do we find A? Well, if you guys hopefully remember from your simple harmonic motion, your maximum acceleration is always given by A equals n squared times A. So n is a sort of angular frequency, or sort of just like how many rotations per second. So in other words, we can see that piston completes 40 cycles per second, so therefore n equals, let's see, we know that it's 40 cycles per second, and the cycle is just given by 2 pi. So we have 2 pi times 40 radians per second, or just 80 pi. A is just amplitude. So the amplitude between 0.17 and 0.05 is just going to be 0.17 minus 0.05 over 2, which is just going to be equal to 0.06. And therefore, your force is equal to m times A, where A equals n squared times A, or capital A. So m is 0.8, n squared is 80 pi squared, and times our 0.06. So if you times this all together, that'll give you about 3031.94 to blah blah blah. Pop that in the calculator, which then gives you to the nearest newton of force equals 3032 newtons to nearest newton. And that will be it for part B. Next, for part C, we have, using the substitution, x equals tan squared theta, evaluate this integral. So since we already have a substitution given to us, we have x equals tan squared theta. We find dx over d theta. That's just 2 tan theta, and the tan is sec squared theta. And overall, that rearrange that, so dx equals d tan theta, sec squared theta, d theta. And now if we calculate the integral, so for 0 to 1 of sine inverse square root x over 1 plus x dx, we also know that x, the limits go from 0 to 1. So for theta, since we have x equals tan squared theta, so theta equals, let's see, tan inverse square root of x. So tan inverse square root of 0 is just 0. Tan inverse square root of 1 is just 1. So tan inverse of 1 is pi over 4. Finally, we can rewrite our entire equation as from 0 to pi over 4 of sine inverse square root of, so x is tan squared theta over 1 plus tan squared theta times the new bit here, tan theta sec squared theta d theta. And now we are just simplifying from here. So 0 to pi over 4 of, let's bring the 2 in front, sine inverse tan squared over 1 plus tan squared theta is tan squared over sec squared theta, which is just tan theta over sec theta. And times that by tan theta sec squared d theta. And if you guys know, tan is just sine over cos, and sec is just 1 over cos. So that's just 2 sine inverse of sine theta, tan theta sec squared d theta. And since we have the integral being between 0 to pi over 4, and we know sine inverse of sine theta is 1 to 1 between negative pi over 2 and pi over 2. That means that we can just directly rewrite sine inverse of sine theta as just theta. So remember, always check your boundaries. So in this case it works. So 2 theta tan theta sec squared theta d theta. And finally, we use integration by parts over here. So that's just equal to the integral of, let's integrate the tan theta sec squared theta, and we'll differentiate theta. So that's equal to, let's see, theta times tan squared theta pi over 4 0 minus the integral of 0 to pi over 4. So differentiating theta just gives us 1. So that just gives us tan squared theta d theta. The first part is just equal to pi over 4 times 1 minus 0, which is just pi over 4 minus the integral from 0 to pi over 4. So tan squared theta, we can just rewrite that into sec squared theta minus 1 using trig identities, d theta. And if you just integrate both sides again, so pi over 4 minus the integral of sec squared minus 1, which is just tan theta minus theta from pi over 4 over 1, which is just pi over 4 minus pi over, that is minus 1 minus pi over 4 minus 0, which is just equal to pi over 2 minus 1. And that will be our answer for part C. Next, for part D, we have the complex number z satisfies modulus of z minus 4 over z equals 2, using the triangle inequality or otherwise, show that the modulus of z is less than or equal to root 5 plus 1. So, using what we have that modulus of z minus 4 over z is equal to 2. So, bringing it up, we have into one fraction. We have the modulus of z squared minus 4 over z is equal to 2. Splitting it up using your modulus rules, we have z squared minus 4 over the modulus of z, 2. And finally, we have modulus of z squared minus 4 is equal to 2 times the modulus of z. Now using this, well, if you guys know from triangle inequality, you can either have, let's see, z plus w is less than or equal to absolute of z plus the absolute of w. So using that same rule, but let's say we replace it with modulus of z is equal to the modulus of z minus w plus w. Well, then that is also going to be less than or equal to modulus of z minus w plus w. So we can rearrange it as modulus of z minus modulus of w is also less than or equal to modulus of z minus w. So the idea here is that we can rewrite this whole thing of modulus of z squared minus 4 being less than or equal to, not less than or equal to, that's just equal to 2 times the modulus of z. So if we use that, then we can just rewrite it as modulus of z whole squared minus 4 is less than or equal to modulus of z squared minus 4, which is just equal to, 2 times the modulus of z. Therefore, we have this sort of equation. So equal to 2 times modulus of z. And if you bring it over, then we have modulus of z squared minus 2 times the modulus of z minus 4 to kind of get a quadratic equation. And if you just, well, let's sort of factorize it out. So using completing the square, you have plus 1 minus 5 less than or equal to 0. So we can sort of simplify this down into modulus of z minus 1 all squared minus 5 less than or equal to 0. Modulus of z minus 1 all squared less than or equal to 5. Modulus of z minus 1 is therefore going to be either between negative root 5 and also less than root 5. So this is how you do your inequalities with a quadratic. And finally, well, therefore modulus of z minus 1 less than or equal to root 5, and modulus of z is less than or equal to root 5 plus 1. And that will be it for part D. And for question 15 overall.